My name is Richard Morin, and this is my AE1601 glider project report. The name of my glider was Big Wing Floater. The glider project description was to design, build, and test a small glider and document the experience in a report. With this project description, there is two main requirements. The glider dimensions must be within 16 inches by 16 inches, and that the glider must travel for more than 20 feet. The success of this second requirement was measured through a tournament-style competition in which each person's glider was thrown. Now that I've discussed the project's guidelines and requirements, let's discuss my design process for my glider. One aspect of my glider that I analyzed was the wing shape. For the wing shape, I considered the four following designs. Middle tapered, which is a wing in which the leading and trailing edge narrows towards the center point in the middle of the wing. Elliptical, which is a wing that is rounded. Planform, which is a rectangular wing. And delta, which is a wing that is roughly in the shape of a triangle. The pros of the middle tapered wing is that it has an element of drag reduction according to soaring skyways and is easy to manufacture. The pros of the elliptical wing is that it has the best drag reduction. The pros of the planform is that it is easy to manufacture. And finally, the pros of the delta is that it has an element of drag reduction. However, each wing type also has its cons. The middle tapered has less drag reduction than the elliptical wing. The elliptical is difficult to manufacture. The planform has less drag reduction. And the delta wing is difficult to manufacture and is actually intended for high speeds. Due to these pros and cons, I chose the middle tapered wing. This is since it has adequate drag reduction while still being easy to manufacture, ensuring that there will be minimal mistakes in its construction. The next aspect of my glider that I analyzed was wing placement. For the wing placement, I considered the four following designs: placing the top of the root cord of the main wing 1 inch, 2 inches, 2.5 inches, and 3 inches from the tip of the nose. The pros of placing the wing 1 inch from the nose is that it pushes the center of gravity further forward. The pros of placing the wing 2 inches, 2.5 inches, and 3 inches from the nose is that there's more room to add Play-Doh weights to the nose. However, there are cons for each design. The cons of the 1 inch design is that there's no room to add Play-Doh weights to the front of the glider, and the cons of the 2 inch, 2.5 inch, and 3 inch designs is that it pushes the center of gravity further back. Due to these pros and cons, I chose to place my main wing 2 inches from the nose. This is since it will push the center of gravity further forward than the 2.5 and 3 inch designs while also having adequate room to add Play-Doh weights to the nose. The next aspect of my glider that I analyzed was tail configurations. For the tail configurations, I considered the following designs for the horizontal wing: middle tapered with a 1.5 inch root cord, middle tapered with a 2 inch root cord, and elliptical and planform. The pros of the middle tapered designs are that they promote drag reduction. The pros of the elliptical design is that it has low drag, and the pros of the planform design is that it is easy to manufacture. However, the cons of both middle tapered designs is that they have more drag than the elliptical shape, while the cons of the elliptical shape is that it is far more difficult to manufacture. Finally, the cons of the planform is that it promotes more drag. Hence, due to these pros and cons, I decided to use the middle tapered 1.5 inch root cord, since it both reduces drag while also aligning with the principle of making the horizontal tail area 1/4 of the area of the main wing according to the Museum of Aviation. So as seen, the alternatives I chose were determined by 1. Evaluating the pros and cons of each design choice, 2. Evaluating the trade-offs between each design choice, 3. Optimizing the trade-offs that I wanted to optimizing the trade-offs that I wanted to maximize in order to contribute to my glider's success. Next, I had to size these components of my glider, creating the guidelines of the main wing 16-inch span in order to maximize the allowed wing size, the fuselage being 12 inches long, shorter than the main wingspan, the horizontal wing being approximately 1/4 of the area of the main wing according to the Museum of Aviation, and the vertical wing being approximately 1/10 of the area of the main wing according to the Museum of Aviation. Ultimately, for the first design iteration, my glider was constructed out of cardboard and followed these design specifications seen below. After creating my first design iteration, testing it was next. It was constructed and then thrown a series of 5 times in order to evaluate a pattern in flight. Through these 5 flights, it was apparent that the glider stalled approximately 5 feet into flight. Ultimately, the glider did not meet the 20-foot requirement in the first round of testing. During my testing phase, I also tested the stability of my glider through the following specifications. Did the glider fly in a straight flight path? And did the glider oscillate during flight? If the desired results were obtained during the test flights, then my glider was considered stable, which my glider was as it did not oscillate while also having a straight flight path. My glider was stalling in flight during testing, so the following changes were made to my glider in order to create improved iterations. My second and third iterations were created by adding weight to the nose, and finally, the horizontal tail of my glider was angled down to a greater degree and the area was increased in order to try and prevent the stalling even further. These changes made in my design iterations would all be seen in my final glider design. In fact, let's talk about this final glider design. This image seen below is what my final glider looked like. It had a main wing fuselage, horizontal wing, and vertical wing with the dimensions seen on the right. And finally, it had Play-Doh added to the nose, functioning as a weight. Here's a video of my glider's flight in which it traveled 28 feet.
See, why did I do that during
The center of gravity of my glider is in the middle of the wing. This is 2 times the quarter chord of the wing. This is not a desirable location, as it should be located further up on the glider in order to promote more aerodynamically favorable flight. Next, the coefficient of lift and coefficient of drag of my glider were determined through a series of calculations seen here. Ultimately, the coefficient of lift of my glider was approximately 0.18, and the coefficient of drag of my glider was approximately 0.001. Overall, the final design of my glider would not have been possible without my prior design iterations. The testing and iteration progression of my glider allowed me to learn that my glider was generating too much lift, allowed me to develop my glider by continually adding more weight to the nose of the vehicle, and finally allowed me to develop a new horizontal tail, one of a deeper angle and larger root chord. Overall, my glider design met all requirements set by the project. My final glider design was 12 inches by 16 inches and flew 28 feet during the tournament-style testing, meeting the 2 requirements seen below. With any project, it is important to reflect on it after it is completed. This project taught me about the fundamentals of aerodynamics, aerospace vehicle design, and the engineering design process, while also allowing me to apply the knowledge we learned throughout the semester in this course. Furthermore, my glider met the requirements and can be improved in order to reach a further distance in the future. In order to improve my glider design, the following actions can be taken. I can add a dihedral, allowing for more aerodynamic flight according to various aviation sources. I can make the main wing shape elliptical rather than middle tapered, reducing drag. And finally, I can move the center of gravity further forward, more towards the quarter chord of the wing. These are my references. Thank you.